Hi, welcome everybody. And today we have Ian Mitchell on the show. Ian, thanks for being here.
My pleasure, Philip. Happy to be here.
Sounds great. So, for everybody that doesn't know Ian yet, so Ian is one of the most amazing scientists in the world. And what I found so interesting, not is he only an amazing human, but he's one of those scientists that is really, really smart and intelligent and can put different and complex topics into easy to understand words. It's a great quality, I feel. And he's very open to things that he doesn't understand yet, or in the past that he hadn't understood at that time, but he allowed for the thought, well, if that's possible, how can we then explain it? And I find that fascinating. And I want to introduce you to the audience today. And so please tell us a little bit about you and maybe also how you even got into science in the first place.
Sure. Well, thank you. I appreciate the introduction. Let's see. So I'm very curious. I've always been overtly curious, and legitimately wanted answers to a lot of questions that probably weren't normal. And in terms of the sciences, I always leaned towards the science because I was mathematics, and then that led into sciences. And I was really very quizzical about a lot of things that had butterfications, like, well, how does something bind? What makes this do this? Why does this react this way? And so initially I studied chemistry. I was, as fate would have it, I was relatively adept when I was young at chemistry. So I got a scholarship for chemistry and studied chemistry, but I also studied music, jazz performance specifically. And they were, people would generally think that they were kind of disparate, but to me they were very similar because it was all about, whether you have a manifest component like some sort of molecule, or whether you have a tone, right? They both have shape, and they both have kind of a vibratory component. And so really the more I got into chemistry, the more it actually started to seem like improvisational music. Really, once you get past the science and everybody's operating at a certain level of proficiency, then it really becomes more about your artistic component. Like, are you elegantly displaying what you're trying to convey here with a molecule, and is it combining the right way? Because generally you can force something and get a chemical interaction, but it's not necessarily the elegant interaction that you're trying to get, and especially for the things that I do, where I, develop a lot of pharmaceuticals and supplements, and, things that are becoming drugs for cancer and Alzheimer's and stuff like that. You can force it and maybe take care of one component, which is generally how things are done in the pharma world. People focus on a specific molecule, and the reason for it is not due to the element, actually due to the it and protect it, so that the tremendous outlay of capital resources that your company is going through can be protected financially. Which personally for me, I'm luckily in a situation now where I don't really have to worry about that. I can just work on what I think will actually elicit the best response, which generally is not one sort of molecular interaction. It's usually, like the human body, a complicated thing that deals with lots of lots of different subtleties, from chemistry and biochemistry and magnetics and electronics and our electrical interaction. It's, we're kind of this amalgam of all sorts of things. And so I personally try and approach how I deal with science that same way, is look at the gestalt of the whole thing and say, okay, this is everything we're dealing with. How do we move that forward? So when I started out doing science, that really wasn't, I think, kind of the common approach to it. And now it is becoming actually more so. You and I've talked offline about how there's sort of a shift, but it's still, there's a lot of obstinance to it. And I think that's because when you spend your entire career working towards one thing in a given framework, you're not terribly inclined to go, you know what? Turns out that framework was wrong. And there's a sort of intellectual honesty that you have to have. And also, I think one of my kids asked me a while back, it was a thing they were doing in their science class, and they had to fill out some paperwork, and they said, the question was, what's the one thing that you would tell a young scientist nowadays? And I think the thing that I would tell them is that science is something that's only looked at through a very specific temporal lens, right? What the best science in the world today is probably going to seem like super amateur science 1,000 years from now. And so even the best, the best guys, it's, the Newtons, the Einsteins, it's really, Newton was aware of it because he actually made the comment of, we're standing on the shoulders of giants. If I had the ability to see farther, it was because I'm standing on the shoulder of giants, or the shoulders of giants, and that applies to all of us, right? So he was super cutting edge then. 100 years ago, Einstein was super cutting edge, and it's a progression. We build on that over time, and so looking at it, back to that question, you have to assess it and say, look, we're doing the best we can. The fastest way to move science forward as a whole is to be absolutely honest about it. And when we don't know, we try and figure it out. And when we get the wrong answer, it's not really a wrong answer, it's just another data point. And it should nudge you in the direction of saying, oh, I am obviously 100% wrong. Like, I was doing an experiment with superconductors and gamma rays using some radioactive isotopes a couple of weeks ago. And I had this whole hypothesis work about what was going to happen. And in the end, I was 100% wrong. It did exactly the opposite of what I thought it was going to do, which actually was a great boon because now I had this entirely new data set, and it was a simple tweak to get it to function exactly the way I wanted it, but it had this whole new property about creating waveguides for gamma rays that I would have literally never come up with had everything worked out flawlessly. And so I think the being open, curious, honest about it. And there are more scientists that are doing that now. Luc Montagnier, the Nobel laureate, who's a French doctor, and he spent the past 15 years working on frequencies in water and been pretty panned for it, like not terribly popular. And the first time I saw his research, I was dumbfounded because it seemed impossible given what I know. And so basically, Montagnier had taken a blood sample and then done a multiple series dilution in water to make it, like 100 millionth of what its concentration was, so that when you ran an HPLC analysis or GCMS, very high intensity spectroscopy, you could not pick anything other than water. But then when he would record the frequencies, email them across to a colleague in Italy, and then they would take those frequencies and play them back into sterile water, they could then put polymerase chain reactors in it and pull out a genetic match to the drop of blood that was supposedly non-existent. And it sounds bizarre because truly to the way we were all trained, that is bizarre. That's not supposed to happen. but when you see something like that, you either have two options. You either go, that's stupid, it can't possibly work that way because that's not how it works. Or you look at it and go, well, I obviously don't understand it now, but what is there? And to Montagnier's credit, in the face of a lot of adversity, he has done that himself. And I think literally everyone would have written him off as some homeopathic quack, save the fact that he was the guy that found the HIV virus and got the Nobel Prize for it. Because usually when you have one of those sitting on the shelf, nobody really messes with you too much. So, long answer.
Well, but those are great examples, and I feel that indeed there seem to be two groups of scientists. Indeed, one group that would say, like you said, this can't be, that's not part of my world, and I'm just not even going to bother to look at it, and they just say this is just not true. Same with Emoto, for example.
Oh,
Obviously, Emoto also showed some amazing things, what's possible with energy, and but then there's still a group of mainstream scientists out there that say that's all BS, right? So how do you see that world shifting, and why is that the case from your perspective, that they close down so much? Is it that they're scared that their belief system about how the world works would be shuttered if they allowed that this was possible? And or what is it, and how can we maybe open up the world a little bit more for the new scientists, the kids today that want to be scientists in the future, that they are more open to this world that you and I know exists.
Yeah, there are definitely two camps. It's fear, like most things. Things are either dictated generally by fear or by love. There's not a whole lot of in between. You pick one camp or the other and you move with it. And of course, things go in gradations in terms of how far to one side of the spectrum you are. Are you having some panic sort of reaction, or are you just mildly inconvenienced by the fear of something being different? The way I think we need to transition through that is just to offer examples, and also that the paradigm needs to change a little bit in support structures, because the way I do a lot of work with one university in particular, and we have joint patents on things together, and very kindly they let me use their entire lab as needed, which is quite handy because I don't have some of the toys that a very well-funded university has. But still, I can see among it's difficult to move things forward because there's such a confined structure in terms of you research what you have grants for, you have to have funding for this and that. And the downside is people get sort of pigeonholed into what they're doing, and they don't have the resources offered to them to dream and to imagine. And those sound like not terribly scientific things, but if you really go back and assess the biggest discoveries in science, I would be willing to bet that you would find that there are a lot of them that things come in a spark of inspiration and insight. And it's not generally that you're just grinding out, doing math for 15 years to come up with some amazing new conclusion. That's generally not how amazing new conclusions work. It's either, something that comes in a spark of insight, or you go, what? How is that even possible? And it sets you down an entirely different path of inquiry. So I think in order to get that to be more the norm, to help out the next generation of scientists, there needs to be some fundamental shifting, almost kind of the way 3M did it, where they would have, 20% of a person's time should be allocated towards random crazy projects, and I think there's a lot of validity to that approach, where you have to let your very eloquently said, imagination is more important than knowledge. One tells you what is, and one tells you what can be. And really, if you want to take things into the future, the guys in my situation who are, hopefully kind of cutting edge scientists, we have to be honest and open about what we're doing, but we also have to be acutely aware of the fact that what we're doing is just one little bitty step as we move forward and open the door for things to progress. It literally was just a couple hundred years ago when the idea of viruses and things, since that's very prevalent in the media these days, that was a concept. Nobody even believed in it. They thought the humors were affected differently. They didn't realize there were actually little bitty things, and that too moved in gradations, because people understood bacteria because they could see them more readily, because they had the equipment to see it. Virus was still completely imperceptible at that point. There were people that had, postulated ideas about it, but it goes in gradations. I think I may have mentioned this to you before, but about a year and a half ago, I wrote a letter to a colleague who used to be with the NIH and is no longer there. They have their own practice now. But and I was looking at the virus that had been going around, and I said, I'm a little concerned. It strikes me that this might actually be a mitochondrial virus. That's something that wouldn't be necessarily delineated by speciation, but really more just by the entirety of a class. Like the class Mammalia. And they wrote back and said, no, it's preposterous. It's, that's sci-fi. Can't happen. You can't have something that, is that broad reaching. Turns out you actually can, and it's both fortunate and unfortunate. Fortunate in that, the perception a year and a half later, it's only been 18 months, is starting to spread. And, people are conceptually being able to grasp the concept of a mitochondrial virus. And but obviously the downside of that is, look, there is in fact a mitochondrial virus. Not so good. It's kind of like, what do you think about the existence of a giant shark in the water beneath us? Impossible. When you realize that it's there, you're like, wow, that's great. My theory has been validated. Also, on the downside, there's a giant shark in the water beneath us. The kind of the upside and the downside. Um, I would I I think if it were personally up to me, I think I would, as a society, start trying to structure things towards the arts a bit more in lieu of just the sciences. Science doesn't seem to be dying the rapid death that the arts did, but really the arts, I think, are in great part maybe what's pushing culture more than the sciences, because one allows you to be creative and free and dream and have wild, strange ideas that you then pursue scientifically and actually suss out the merit of. And that makes sense to me. Are you familiar with the STEM movement? I'm sure you've heard of STEM. You have,
Yes.
so
Not
now
very
it's,
familiar, but definitely heard of it. Yeah.
yeah, well, now it's become the STEAM movement. So it's, they've added the A in there for arts, which I think is critical because it's a necessary component. You're not just an isolated person. If somebody said, we're only going to give oxygen to your brain, well, that really doesn't do a whole lot for your heart or the rest of your body. We're kind of creatures in totality, similarly in our culture, as we move forward with science, we have to address all of it, because part of it is just wild, crazy, fanciful dreaming that you then have an idea and go back up with the math and the rigor academically and say, okay, look, we've done it. Here's what it is, and here's how it works. I mean, I can tell you matter of factly, there are a lot of results that I've had in my own lab, even in the past month, where I go, what the hell is that? How does that work? Like, that's not supposed to happen. And then you don't go, well, that's not supposed to happen and I can't justify it to committee, so I'm just going to brush it under, and never look at it again. My thinking is, when you see that, you jump in full force and go, well, look at that, there's something that I didn't expect. Because that's where the boundaries get pushed, literally, right? You're pushing the boundaries, and because of that, science as a whole expands, and it allows all of us to expand. And I think, I know there are some people that I know personally that are doing that, but it's gonna take a little while. I think, some of the generation that's preceded us is going to have to, unfortunately, like most things, die off a bit so that new fresh ideas can come about.
Awesome. And there's so much wisdom in what you say. Thank you very much for that. I want to touch real quick on the topic of longevity because I find it fascinating, and I think it's fascinating for humans in general and has been for such a long time, right? I mean, it's always been written up in books and in stories, and people wanted to get this magic apple, that they bite and then they live forever or live 500 years. It seems that we have been and are currently in a time where really things are shifting. From my perspective, really living until we're like 70 or 80 is young. I call that extremely young, actually. And there are a lot of reasons to why I see it this way. And if you step back and think, okay, so what if we could be 300 years old, just to say that, how would everything else shift? How as a society would we develop? How would we look at things? How would we plan long term? And because currently and in the last 2 decades, we've seen so much short-termism, right? We've seen it in the business world. We've seen it in every other part of the world as well. And I know that you have been working on some amazing things in regards to longevity. And I see, obviously, quantum energy and specific frequencies as one ingredient for that in the future. I know firsthand, like you, that C60 plays a role in that. All of these two things are things that are not mainstream at all, right? They're living a life in a niche, And my big question would be, okay, so how do you see these niches develop into possibly a broader spectrum and segment? And what else is there that I haven't mentioned that you may have tapped your thoughts into? And what do you seriously believe will be possible in terms of age, just from your perspective, in the next, I don't know, 5 decades? What can we achieve from your perspective?
Well, yeah, I obviously have spent a lot of time and patented a bunch of stuff around that. The idea of living, I don't know, 5 or 6 years, actually maybe a little bit more than that, maybe 7 or 8 years ago, I did some experiments, and they took over a year because I was using mice that were supposed to live half a year, P53 knockouts, and was able to extend their lifespan 93% on average, some a little bit longer, some a little bit less, which would be the equivalent of a human living to about 152. It was eye opening, and it was interesting to me, not so much because of that experiment, which was neat, but it made me think, wow, well, what really happened? Because their curve was different. It was kind of like they hit middle age and stayed at middle age all the way until the last 2% of their lifespan, and then they precipitously fell off. And I mean, everything just went, to hell in a handbasket, organ failure, everything just fell apart. But it was like they were aces, they were all healthy and happy and strong and milling about their cage and, looking great until the very end. And then they would just go whomp and drop
Yep.
off. And I started thinking, well, why is that? What's happening there? And in the case of those guys, the shift was carbon 60, and that was just due to negation of oxidative stress and an upregulation of mitochondrial function. So you knock out the oxidative stress and you're not actually additively putting more energy into the system, but it has the net appearance of more energy, because when you don't have to deal with having electrons stripped off from oxidation, there's more that's able to go into the rest of the electron transport chain. And so you end up with what we found was between 18 and 58.3% jumps in aggregate energy levels and output of actual ATP. And, and we did all that stuff just through, using photomultipliers and equipment at the university, so we could actually suss out what is the exact percentage ATP increase. And so that was pretty well quantified. But it got me to thinking, well, what else could you do? And so at this point, I would say I've easily hit it probably 300%, maybe 400% without much issue. And it's basically, you have to take, for humans, you have to take into account methylation, mitochondrial function, ATP output, and the length of the telomeres at the end of the DNA, that repeating sequence. And when you figure out how to manipulate all those things, it's not really that tricky. The thing that I think is more interesting is that all of those biological interventions can still only take you so far. There's an energetic component that you can't bypass. And nature is really brilliant and incredibly elegant, seemingly from our perspective, sometimes a little brutal, because it's just done without bias and very judiciously. But your consciousness as a whole, and this sounds a bit esoteric, so I would ask people, just put aside the white coat syndrome for a second, and it sometimes meditating and things like that, they're the best science in my estimation, because you'll read about something and then you can do the experiment, and the experiment may be, you meditate 2 times a day for 20 minutes. It may be you spend 4 hours a day in meditation, whatever your particular thing is, or it may be you go do devotional work, worshipful sort of stuff, whatever your particular bailiwick is, in that. Because I think people have a different proclivity towards certain types of things. Like, I actually like the knowledge component. A lot of people like devotional sort of stuff. It makes their heart swell. But the energetic component of your consciousness is really what I found to be kind of the sort of nature's kill switch. It's the thing that, until you bypass your own kind of ceiling in your own consciousness, doesn't matter. You can do a lot with biological intervention. You can bump it up a couple fold, 3, 4 fold, but that's it. Then you hit a ceiling, and you hit a ceiling because collectively, as a species, that's where you have all arbitrarily decided your ceiling will be. And again, that it's hard to verify some of the stuff, and I can't really say that as a scientist. I can say that more as a somebody who's very, very much a scientist by profession, but also realizes that there's a whole lot more going on, and there's a component of, you can call it the universe or God or energy or divinity or whatever you want to call it, that's really the substrate that all of this stuff is built on. And until you're willing to look at that and go, there is something very tangible here, you're going to be capped out and limited, because you can't think your way past something that is more subtle than thought. You just have to have an awareness of it. And when you can move to that point, and you actually are coming from that standpoint, oddly enough, I don't know that you would really necessarily want to continue pushing the bounds of longevity, because eh, what what's the real need for it? I mean, to a certain extent, I personally, for myself, am trying to push my own bounds a little bit, because I have what I would consider to be some things that I really want to achieve before I leave. And that's it. And at the point at which I've achieved those things, and set things up in a better way for the people that will follow, I'm good. I don't really need to stick around and continue trying to eke out, a body that can only handle so much energy to a certain point. Because if I understand evolution properly in my, kind of armchair theorizing about it, really a body is only going to take you so far in terms of the evolution of your own consciousness. At a certain point, you have to leave it like a raft on the shore and just continue your march forward. So mechanically, sure, I can bump things up a couple 100%. But beyond that, it's really going to be up to a human to elevate their consciousness to the standpoint where they don't have to degrade if they don't want to. Because anybody who's just looking at it as a tangible meat suit function, like, this is the biology, and that's where it stops, you're never going to get the right answers. We did a bunch of work in my lab on regenerative medicine, specifically for wounds and wound healing. And when you only look at the biochemistry of it, you cannot solve the puzzle, or at least I was not able to solve the puzzle. And the puzzle being, how do you fully regenerate these things at a much more rapid pace? And the rapidity was directly correlated in terms of its impingement by virtue of a lack of energy. And the same thing applies to people. You can push it biologically so far, but you really have to broaden your horizons and say, look, there's actually a lot more going on. There's energy fields around the body that have an impact on the body. um, my experience thus far has been that's actually more impactful than the things that are just on board. And for scientists who think that's not the case, just read a bunch of the papers on transcranial magnetic stimulation. It very, very clearly and demonstrably shows that you can manipulate all of the biological systems without even interacting with it physically. And that goes back to the point that it's, do you have blinders on? Do you take them down? Because it is a little daunting, because I've had to move the scope and the breadth of what it is that I understand a lot, and it takes a lot of effort. I mean, I read incessantly, I study all the time, I'm constantly taking nootropics and doing literally every day, multiple times a day, meditation to broaden my consciousness, and brain exercises to make the interface of my consciousness to tangible reality operate more effectively, so that I can move these concepts through. Because otherwise, I just hit walls. And I shared with you prior to recording today that now sometimes I'll ask a question, and it will, in theory, have been something that I've been working on for years, and I could not get the answer. And now it literally just drops into my head, and then I can go back and test it out and go, well, I'll be, look at that. And I think part of that is that I wasn't actually in a state where I could conceptually grasp it.
Absolutely fantastic. And I hope that everybody uh, gets really some valuable impulses from this and what Ian is sharing, because there's so much in that. And I would truly agree with everything you said. And where do impulses come from, right? Maybe we cannot really explain where impulses come from. I mean, we sort of can, probably, you and I, but we don't need to understand it really. What we need to understand is that there's more than just our brain. It's not like a closed mechanism and everything is happening in the brain. No, we can open up. And the more we open up, the more things that, help us on our path can come in. And that's exactly what you're describing too. So I think this was full of so much valuable wisdom for everybody. And we went a little bit over, so let's maybe um, yeah, stop it here for now. And I'm already looking forward to a part two that would go way beyond introduction, so I can't wait
I'd
to
love
actually
to.
chat with you then, and then also talk a lot more about the things that you're actually now working on. We touched a little bit on the concepts, longevity, and your
Mhm.
interest levels and all of that, but then we can go a little bit more into the
Oh yeah,
details that
I'd
you're
I'd
working
love to
on.
nerd
And
out.
that sounds fantastic. So Ian, thanks so much for your time today. And yeah, all the best to you.
Thanks, Philip. My pleasure. Take care.
All right, you too.